Hello, in this video we'll be solving the mathematics examination 2019 conducted by CBSE. This is set 3 of mathematics examination. The first question we have here is finding the LCM of a and b, where a is x cube y square and b is xy cube. So we know that LCM stands for least common multiple, which means that we have to find the least power of x and y common in both a and b. So as we can see here, the least power of x in both a and b is 1, and the least power of y in both a and b is 2. So the LCM will be x to the power 1 and y to the power 2, xy square. Moving on to the second question, here we have how many two-digit numbers are divisible by 3. So the first two-digit number divisible by 3 is 12, and the last two-digit number divisible by 3 is 99. After that it turns to 3 digits. So we can see here that it becomes an AP with 12, 15, 18, 21 up to 99, where the first term is 12, the difference between each term is 3, and the last term is 99. We have to find the n. So we know that the formula for an equals a1 plus n minus 1d. We put in the values of a1, n, a1d, an, and we get the n. So we see here that n is 30. So there are 30 two-digit numbers which are divisible by 3. In the third question, we are given that the line DE is parallel to BC, and from this figure we can see that the angle ADE is equal to the angle ABC. Also, angle AED equals angle ACB. So these two triangles are similar, so we can write the ratio of the sides in a way that AD by AB equals DE by BC. Also, if we draw a perpendicular to BC, it will also be perpendicular to DE, and in the smaller triangle of ADE we take the half triangle, and in the bigger triangle ABC we take half the triangle. These two triangles will also be similar, meaning that the height, the length of the perpendiculars will also be in the ratio of the sides. So the whole area of the smaller triangle and the bigger triangle will be in the ratio of square of sides. Here AB equals 9 and AD is 1, so the ratio of the area will be 9 by 1. In the fourth question, we are given one point B on the circumference of the circle, and we are given the center of the circle, and we have to find the coordinates of A, which is the other end of the diameter drawn from B. Because AB is the diameter, it passes through the center, and AO equals OB. So the length of AO and OB are equal, the ratio 1 to 1. We use the formula x1 equals x0 plus x2 by 2, and similarly for y. We just input the values. x1 is the center, x0 can be B, and x2 is A. So we input the values and we get x and y. We have got the coordinates of A. In the fifth question, part 1, we have to find the values of k for which the roots of equation x squared plus 4x plus k are real. For the roots to be real, d should be greater than or equal to 0. If d is equal to 0, the roots are equal but still real. D is nothing but b squared minus 4ac, where b is minus 4, a is 1, and c is k. We input the values, we get 16 minus 4k greater than or equal to 0, k should be less than or equal to 4. Part B is we have to find the value of k for which the roots of the equation 3x squared minus 10x plus k are reciprocal of each other. Reciprocal meaning if one root is r, second root has to be 1 by r. So clearly the product of the roots will be 1. Also, product of the roots is c by a, where c is k and a is 3. So k by 3 equals 1, k equals 3. In the sixth question, part 1, we have to find the value of a given tan 2a equals cot a minus 24 degrees. We convert this cot a minus 24 degrees to tan so that we can compare the angles. We deduct this angle from 90 degrees to make it tan, and we solve for a. We add 2 and pi because there can be infinitely many solutions for a. In the second part, we have to find the value of sine square 33 degrees plus sine square 57 degrees. This is pretty straightforward. Sine 57 degrees is equal to cos 33 degrees. We replace it by cos 33 degrees. We get sine square 33 degrees plus cos square 33 degrees, which equals 1. In the seventh question, part 1, we have to find the number of two-digit natural numbers which are divisible by 7. Like we did in the previous questions, we do the same way. The first two-digit number divisible by 7 is 14, and the last two-digit number divisible by 7 is 98. So we again have an AP where A1 equals 14, the difference is 7, and the last term is 98. We have to find the n. We use the formula for an. We input the values of an, a1 and d. We solve for n equals 13. In the second part, we are given that the sum of first n terms of an AP is n square, and we have to find the 10th term. Now, one simple way to find the nth term is we get the sum till nth terms, and then we calculate the sum till n minus 1 terms. We deduct, and the difference will be the last nth term. We have used same logic here. To find the 10th term, we calculated the sum of 10 terms, we calculated the sum of 9 terms and deducted. We will get the 10th term. In this question, we are given a coin which is tossed 3 times. We are noting the outcome. If we get the same outcome all 3 times, it is considered a success. We have to find the probability of losing this game. Now we know that the coin is tossed 3 times. The total outcomes will be 2 raised to the power 3, which is 8, and all the outcomes possible are mentioned here. The success outcomes are when all three results are seen, which can be either all heads or all tails. So total 2 outcomes out of 8 are for success. That means for losing, there is total 6 outcomes out of 8. The probability of that is 6 by 8, 3 by 4.75. In this question, we have to find the ratio in which the line segment joining the points 1, -3 and 4, 5 is divided by the x-axis. Now, because the point is on x-axis, we know that the y-coordinate of that point will be 0. We assume the ratio m1 by m2 to be k by 1 to simplify it, giving m1 to k and m2 to 1. We use the formula here, y equals m1 y2 plus m2 y1 by m1 plus m2, considering m1 by m2 as the ratio. Y is 0 because the point lies on the x-axis. So we input the values of m1, m2 and the coordinates y1 and y2. We get k equals 3 by 5. Now we just input this value to the x formula to get the x coordinate, and we get the x coordinate from this calculation to be 17 by 8. In this question, we are given a die which is thrown only once, and we have to find the probability of getting a prime number. Now we know that the numbers on a die are 1, 2, 3, 4, 5 and 6. Out of these 6 numbers, the prime numbers are 2, 3 and 5. Total 3 numbers. Possible numbers are 6. Total favorable prime numbers are 3. So the probability of getting a prime number out of a throw of a die is 3 by 6, which is half. The second part, we have to find the probability of the outcome when a number that lies between 2 and 6 comes up. Again, the total number of numbers between 2 and 6 are 3, 4 and 5, which is 3. So the probability of getting them is 3 by 6, which is again half. In this question, we have to find the value of c for which these 2 lines have infinitely many solutions. For a line to have infinitely many solutions, it has to overlap the other line. So all the coefficients of both the lines should be equal in the ratio, meaning a1 by a2 should equal to b1 by b2 should be equal to c1 by c2. We just input the coefficients that are given here as a, b and c. We use the b and the c part. C is cancelled out. We get 3 equals c minus 3. C equals 6. In this question here, we have to find the HCF of 1260 and 7344 using Euclid's algorithm. Now we divide the bigger number by the smaller number. So 1260 is going to divide 7344. We use 5 as the multiple and we get 6300. The remainder is 1044. Now we use this remainder to divide 1260. We keep on doing this until the remainder is 0. We see that the remainder is 0 when we divide the previous remainder by 36. Hence 36 is the HCF. Second part is that we have to show that all the positive odd integers are of the form for q plus 1 or for q plus 3, where q is some integer. Again, using Euclid's theorem, we know that if there exist any two positive integers a and b and two other integers which are q and r, which are unique between each other, meaning that q and r are not equal, then a equals bq plus r. Now let us say that b is 4 because it can be any positive integer. Then we get a equals 4q plus r. R works as the remainder, so it has to be less than 4. The possible values of r are 0, 1, 2 and 3. So we use these values in the equation of a. We get a as 4q plus 1, 4q plus 2 and 4q plus 3. We know that 4q and 4q plus 2 are gonna be even integers, so 4q plus 1 and 4q plus 3 shall define the whole range of odd integers. In this question, we have to find the zeros or the roots of the cubic polynomial given here if one of its root is 1. Now, as x equals 1 is one of the root, x minus 1 is gonna divide this cubic equation perfectly. So we divide the given cubic equation by x minus 1 to get a quadratic. First, we eliminate the highest powered term, which is 3x cubed. We have an x here, so we use 3x squared to eliminate 3x cubed, but we also get negative 3x squared. We need plus 10x squared, so we get 13x squares more. We already have x here, so we use 13x. We get 13x squared, but we also get negative 13x. We needed only 9 negative x, so we add 4x, but it also gives us minus 4, which we need as well. Hence 3x squared plus 13x plus 4 is the quadratic polynomial. Now if we are able to find the roots of this quadratic polynomial, and we already know one root to be 1, we will get all three roots of the cubic polynomial. Now easy way to get the roots of a quadratic polynomial is get the d, then negative b plus minus square root of d by 2a gives us both the roots. Another way is we break up the midterm to get the product of the first and the last term. So here we see that the product of first and last is 12. We break up the 13 to be 12 and 1, and we get the roots as negative 4 and negative 1 by 3. In this question here, we have to find the length of TP, where there's a circle with center O and an external point T. Two tangents are drawn from T to this circle. Now by theorem we already know that TP equals TQ because these two are tangents from a single point. OP and OQ represent the radius of this circle. Now in the triangle OPT and OQT, we have OPT and OQT as 90 degrees because these are tangents to the circle. Also OT are common in both, and OP and OQ both have radius, so has to be equal. Hence the triangles are congruent. Also, angle TPQ equals TQP because TP and TQ are equal, and that makes TPQ isosceles triangle. So OT is going to be a perpendicular bisector of P and Q, meaning PR and RQ both are of 4 length. Now in the triangle ORP we have one right angle at R. Using Pythagoras theorem we get OP square is OR square plus RP square. This gives us the value of OR because we already know the value of RP and we already know the value of OP. So OR equals 3. In the triangle TRP we get TP square equals PR square and RT square. And third angle TOP we get TP square and OP square equals RT plus OR whole square. We get TP in terms of RT, OR and OP. In the previous part we got TP in terms of PR and RT. We equate both of them and we get the value of RT. Once we get the value of RT, we can input it in any of the equations to get the value of TP. In this question, we have to prove that 2 plus square root 3 by 5 is an irrational number, given that square root of 3 is an irrational number. So first we go against this hypothesis and we assume that 2 plus square root 3 by 5 is rational. We take 5 to the right side. 5 is rational number, so 2 plus root 3 will still be rational. We take 2 on the left side, it becomes 5x minus 2, and on the right side it becomes root 3. It should still be rational because we just subtracted minus 2 from right hand side, which will not change the rationality character of the number. But it is given in the question that root 3 is irrational, hence the conclusion that we came to is wrong. This proves that 2 plus root 3 by 5 is not rational, hence it is irrational.